Hello, and welcome to PyData Global 2021. My name is Gaby. I'm very happy to be here and be your host for this session. And I would like to welcome Gaby to talk a topic about the data science in enterprising holistic approach. And Gaby is really good and in statistics and is found love in programming, and he's passionate on data science. And after completing the Master of Science in Business Analysis degree, she joined the brilliant creative and human and fun AI and automation team at CGI inside of technology practice. So let's move the time to Gaby to share her session. Thank you, Gaby.
Thank you, Zach. Let me get things going here. So as he mentioned, I'll be talking around data science in the enterprise, where I'll be tackling data science from a holistic approach today. So like he mentioned, I'm a senior data scientist at CGI on the AI and automation team. I help our clients not only implement data-driven solutions, but I act as a thought leader. I help advise on strategy and growth opportunities for analytics inside the organization. I've seen a lot of successful and some not so successful data science projects. So today, what I really wanted to do was just share some of my best practices that I've learned to ensure that your next data science project is set up for success. So just an agenda here, I'll start with a quick overview of the main differences between EDA and production. Then we'll move into the process that we can follow when we're developing data science projects that need to be productionalized. And then I'll walk you through these best practices with a current example that I've done at my client. That's an oil and gas client where we've been doing some anomaly detection on their IoT data coming from compressors. So I'm sure many of you have seen this statistic before or something pretty similar, but the reality is that only about 20% of analytic insights will actually deliver business outcomes. And the reason for this is because so many projects get stuck in that exploratory phase, and the analysis or models are not deployed across the organization to actually start delivering that business value. And we spend so much time exploring that data, and proving a model could be beneficial here, but how do we actually take it across to that finish line and ensure that, it's not only being implemented, but it's actually being used day to day in the end user's decision making? And the answer to that is to really focus on your people and your processes that you have in place. So whenever we think about a transformation, we think in terms of people, process, and technology. Today, almost every organization is going through a digital transformation, and AI is kind of the heart of that transformation. So when we think about AI and what's needed from a people, process, and technology standpoint, what we see is that companies are actually rarely lacking data, tools, or things that fit inside of that technology bucket. There's a plethora of data out there and many open source tools available to start analyzing your data. What most organizations are lacking, though, is centered around a people and process domain. So correctly structuring your analytics team within your organization to drive out those projects is a huge step that needs to be taken by an analytics leader to make sure that you're enabling a data-driven culture and you're helping your company realize, the full potential of analytical capabilities. What's even more interesting is, not only does setting up this team allow data science to grow and flourish, but it actually helps the business understand how to utilize data scientists to their full potential. So as data scientists, we have very desirable skill sets. We know how to program, we know how to visualize and analyze data, as well as build predictive and statistical models. So, due to this knowledge across multiple domains, we often get pinged and pulled to put out fires, resulting in data science initiatives getting thrown to the back burner or projects being paused instead of working through a deliberate project and process scoped out by an analytics team. I know I have a lot of heartburn here. This has happened in many of my projects. So this is just why it's so important to ensure that you have a process that both the business and the data scientists are educated around so that you can push that project forward through any obstacles that may arise. Before we dive into how to structure a project for success by focusing on the people and process, I first want to touch on how different the people and processes can look from an exploratory project to a project that must be productionalized. So let's start where we spend the most time. In an EDA project, a bulk of your time is going to be spent on exploring the data, doing model development and assessing that feasibility. If you're building a model that needs to be productionalized, there needs to be a really heavy investment up front on defining that use case and setting up the correct team. There's also going to be a heavy investment at the end when you're operationalizing those results. In terms of who's involved, on an exploratory analysis project, the business usually comes up with the idea and then hands it over to a data scientist and data engineer who works through that process hand in hand. But if you're building a model that's going to be productionalized, you absolutely need to involve colleagues from the business, coupled with your data scientists and data engineers who are working together, if not every day, every week. And lastly, if we look at the process and the resulting output, an exploratory analysis project, you'll likely be developing until you have that final model or analysis. And then at that point, you're going to present it out, maybe using some visuals, and you might have a local model ready to show that demo. But if you're building a model for production, that process is much more involved in terms of reading out your results early and often to get that feedback from the business. This way, the output is a model that is ready to be deployed into the business, and that value has already been predefined. So we're going to take a closer look at what that use case process roadmap should look like, touching on all those things that I just mentioned, and hopefully we'll give you a successful data science project that ends with a model in production. So there's really two major phases to this use case process roadmap. The first, like I previously mentioned, is that really heavy investment upfront in defining an achievable use case. So this is made up of 3 parts. We must first identify our use case champions and build a team around them. They are the leaders who are trusted and have a really good understanding of the problems that the business faces and how data can help solve those problems. Secondly, we need to educate the business around what data science can do versus what it can't do, and conduct early feasibility assessments. Once you have done both these things, it becomes really easy to use that team to then discover possible use cases and prioritize them based on business value and technical feasibility. Again, by focusing on this upfront, you're really setting yourself up for success versus getting through that exploratory phase and realizing, hey, there isn't much value here, and this use case isn't really feasible technically. Once you've set yourself up for success, you have that right team in place, you've picked a use case that has value and is feasible, then comes that second phase, which is the execution. In this phase, you'll be driving out the development in a really iterative process coupled with the business. And once you get that okay, that the model is looking great, it's providing the outputs we want, you're going to deploy those models into production so they can be used across the business to aid in decision making. So we're going to take a pretty deep dive into each of these steps, starting with the structure of the team. So aside from creating a blended team that involves, not only technical resources, but those key players in the business, that most important piece of the team is going to be that use case champion. This is a person that's going to drive out the project from the business side. They understand the value that data can bring to solving business problems. And they're going to advocate for that project and be tied to its success. They'll also come to the table with some KPIs in mind, how we can measure the model's outputs and ensure that there's value. But really, above all else, what this person needs is to be trusted across the business, because when it comes to deploy these models and you need to shift those end users into an analytical mindset, you need to start using the output of these models. If that use case champion is behind the project, then you're going to get all your end users behind them as well. Of course, there's other key roles on the team that must exist. You need to have your data engineers and your data scientists who can actually drive out the technical implementation. But you also need to make sure you have SMEs and end users on your team. So when you're creating a use case, you need to have the end user in mind the entire way. They're the only ones who can tell you if your modeling outputs are being understood. And at times we forget, right, that these end users of our models are not always technical. So we need to make sure that they can take action and they understand how to interpret those results. Also, many times as data scientists and data engineers, we're not experts in the problem at hand. We're experts at building models and analyzing data. So we really need a SME or a business analyst who has worked with the data before, or even been on the ground and encountered, that exact problem that we're trying to solve for many times, so that we can fully understand what we're trying to solve for. Having this input from SMEs can really speed up your efforts because they're able to give you that immediate feedback and answers to any questions you may have. And of course, in order to keep this project on track, we're going to want to have a project manager. They can be from the business or the IT side. It can be a blended role. It doesn't matter. All that matters is you have someone there that's prioritizing this project and blocking and tackling any obstacles or distractions that may arise. Now, this is just a broad template of the roles that should be present. Sometimes a data scientist and data engineer, they might end up being the same person who straddles two roles. Other times, a SME may be the same person as your end user and vice versa. And in some projects, you might have two end users helping you, and another one you might have one. Just what's important is that you have at least someone representing each of these roles at a minimum. So now that we have, our team roles outlined, we understand who could be a part of our team. Let's talk about educating those potential team members so they understand what is and is not possible with data science and with the current tools and technologies that we have available. A lot of times this step gets forgotten, and what ends up happening is kind of a fundamental misunderstanding between the business and the technical team, especially when the technical team has to come back and tell them, oh, this isn't going to be possible, or our model ended up having a poor accuracy, we're not going to move forward. It's also better to assess that technical feasibility early, so when we're prioritizing those use cases, we know what's going to be easy and what's going to be a mountain to climb over in terms of that technical feasibility. And it also helps the business come to the table with use cases that can be solved for in our current state. So for understanding data science, we usually like to host an introductory workshop to those who will be working with the analytics team. We invite people from all around the business, and what we really focus on is demystifying data science. So we talk about what it is, we give real world examples to help them understand, we go through our methodology, which you guys will see here in a second, and we even educate them on some basic models such as linear regression, decision trees, and the difference between supervised and unsupervised learning. For those on the IT side who may have, familiarity with data science, but not really understanding what tools need to be used, we host a separate workshop building off the first one where we go over how to use Python for data science at a very high level. So they at least become familiar with the effort and the tools it will take to solve the problems. And along the way, you're helping those around you upskill so that later on when these models are deployed in the greater architecture, they can help maintain them. So we start out with, an introduction to Jupyter notebooks, open source libraries, Python, and a focus on pandas and transforming and storing data. Once the business and IT is familiar with what data science is and the tools needed to solve it, we have another workshop where we discuss the technical feasibility of building production-facing models. So we ask a lot of probing questions like, what are the possible data sources that we have available to work with? Is there data currently that we don't have available to us that we would like for these use cases? That means we're going to have to build a new data pipeline. How often are all these data resources getting refreshed? If we come to the table with a use case where we want a model running daily, but we only get that data refreshed weekly, that's not going to work, right? And we want to make sure that we figure that out up front before we get too far into it. Another really important question we ask is, has the accuracy of the data been validated? Do we trust it off the bat? Or are we going to have to spend some time doing analysis and possibly a big effort to clean it up? And lastly, we need to be thinking about what tools we currently have available to us for modeling and transformation of data. If we don't have tools available, how are we going to invest in a new one? And do we have the skill sets needed on our team? Do we have data scientists, data engineers? Do they specialize in specific areas? All these things are going to help us scope out our use case, figure out if we need to invest in new resources or tools, and help in setting up our project plan and timelines. So we have our team outlined and educated. Now comes this fun part, right? Let's figure out what use cases we have and which ones we can start working on. So your analytics team may already have some use cases, brought to the table, or you might have to conduct a workshop for that. But regardless, once you get some use cases, you need to evaluate them on two aspects. So that technical feasibility we've been talking about, and then the business value. We just got all that information about what data we had available, the skills and the resources. So per use case, knowing what we know in that area, what we need to do is rank it from 1 being, this is not possible in our current state, to 5 being, we could do this tomorrow if we wanted. Then you'll do the same thing with business value, with 1 being, this brings little to no value to the business, or 5, this is extremely valuable with big potential cost and time savings. So it might be apparent that those in that top right corner are the use cases we're going to want to drive out first to give us a really quick win. To enable data science across an organization, it's much better to start with something small that drives business value than to aim really high and fail. Then you'll be giving this perception across the organization, that data science projects are risky, they take a long time to complete, and they might not even be successful. By aiming for these more attainable use cases, you're showing success to get the ball rolling And all the while, while you're working on these, you're actually investing in resources, getting new tools and technology so that down the line, you can tackle those bigger ones highlighted in red. It's also really important to note that this isn't a static process either. You don't just do this once and forget about it. You're always going to want to be reprioritizing, especially as new use cases come down the line or you invest in those new tools and technologies, and especially what your current business climate is. So this is an ever-changing cycle that you need to iterate upon often with your business and IT. So let's say we picked one of those use cases in our top right corner to start on. We already know what roles we need on our team. We know the feasibility and the business value. So it's time to really dive in and get that development kicked off. You should spend no more than a week getting that team together, setting the expectation, picking the KPIs, and officially launching that project. Following that official launch, now that you know your team members and everyone is acquainted with the expectations, it's time to revisit that use case that was proposed and have a couple of discovery sessions focused around exploring the data and figuring out what types of models you're going to throw at this problem. The technical resources should also be relying heavily on the business in this space to help them understand what the actual business need is in detail now that they have those SMEs and end users at their disposal. Once you feel comfortable with, the data that you've analyzed and your approach that you're going to take, it's time to begin that iterative cycle of prepping the data, modeling and validating, and then synthesizing those results. We like to keep these iterations at 2 weeks maximum so that we're not spinning our wheels on something for too long before the business tells us, it's not what they were looking for. This step is really important in the process because this is where you're going to be getting feedback that feeds what that next iteration should be. We like to live by the phrase, present early and present often so that nothing shocking is going to come out of this readout. And even through the process, you should be having daily stand-ups with your team members, asking them questions to help you through unblockers. So nothing surprising should come out of this. Once you have done enough iterations to where the business and yourself are happy with that final model and output, it's time to engage those stakeholders. So maybe some executive leaders, department managers, and others to read out your final results and recommendations. This is a really important step in the process because this is where you get that buy-in from across the organization. So it's really time to prove that value of your work. And if things go as planned and everyone is happy with the project outcome and results, that final step in the process is to deploy that model across the organization. So we've gone to this point thanks to all our due diligence upfront by focusing on our team and our process. Now it's time to deliver that final result. So as we know, there's really no value, in a machine learning model unless it's deployed into production so a business can start using it to make decisions. But what I want to caution everyone against is that there's really no need to boil the ocean coming out of the gate, right? So start small, pick a single department or area to pilot the model on. This will give you time to prove its value with the business by tracking its success. So using the KPIs decided upon earlier in the process, measure against these once your model has been deployed, and make sure, if possible, you create a feedback loop so that your end users can tell you if your predictions were correct or not. After analyzing the results for a meaningful period of time to actually recognize those improvements, then you can expand to other departments or the entire organization with the evidence knowing that this is helping the business. This would also be a really good time to engage change management with a bigger audience who may or may not have used modeling outputs before. And even if they have, right, every output is different. The way they interpret it and act on it is different. This should not be left up for the discussion, right? They need to know exactly how to use it. The biggest end goal here is that your users trust your model so that data science initiatives can continue to thrive in the business. So you want to do everything in your power to make sure your model and outputs are trusted. So now that you know the best practices, let's put those to the test and see how I use them in one of my most recent projects for a client in the oil and gas sector. So this client had defined a really bold vision for their organization in which they wanted to leverage near real-time unit monitoring, advanced analytics, and integrating all of this into their mobile tools to change the way their organization is run. In phase one, my team and I spent a really good chunk of time standing up their analytics strategy and environment, as well as driving out some proof of concepts. We set up their big data platform using Azure and Databricks as the heart of that solution. We built data pipelines, pulling in IoT sensor data, as well as data from across other parts of the organization so that we had it in one centralized area. And we engaged in 3 proof of concepts or exploratory analysis projects in tandem to showcase the art of the possible and what we could do once we had this whole environment set up. And then we are currently in phase 2 where we have started building those productionalized models. So right now I'm going to walk you through our valve failure anomaly detection project where we were successfully able to build and deploy a model together with the business using all those strategies we just touched on. So the first step in the process, creating that all-star team. Fortunately for us, like I mentioned earlier, this organization had a really bold vision and they knew that we were going to need a lot of resources on the analytics side to make this come to life. So we were given 2 workstream leads, one from the analytics side, one from telematics, that really led the business and acted as those use case champions for all of our use cases. They're able to hold those SMEs accountable and the end users accountable for being engaged in the project and driving that value. For end users, we had field service technicians, business unit VPs, and service area managers at our disposal who we could use in our projects to guide us when creating the model and outputs, because they would essentially, right, be the ones using them at the end of the day. And some of them also served as our SMEs because many of them had come from a hands-on background, working with that equipment and had a deep understanding of how compressors should operate. And we also added in a few engineers to give us a rounded perspective. I was the data scientist and data engineer for these use cases, supported by a business-facing project manager that would keep our projects on track and focused. We quickly realized that a lot of these end users and SMEs, although they knew a lot about compressors, they did not know a lot about data science. And so it was a new concept for them. And we held training sessions where I went over basic concepts in data science, but I tied them directly to use cases within the oil and gas space to give them a clearer understanding. In that same session, we also covered the type of data that we currently had available for the use cases so that the team could come prepared to that discovery and prioritization workshop with some ideas in mind. Here, it was really important to arm our business with as much information and understanding as possible so that it wasn't a wasted effort and actual meaningful conversations and ideas were had in that workshop. And so moving into that workshop, it ran for about 3 to 4 hours. It was very successful. We had people from all across the business, along with people from IT involved. To help actually get this conversation started, we came prepared with some historical data analysis about common parts usage, which parts were kind of the most expensive when they were repairing those machines, hoping it would trigger some thoughts and ideas, which it did. And coming out of that meeting, anyone who had suggested a use case was tasked with filling out this use case template form. The form included an area to talk about the problem, the potential value, assess that technical feasibility, and think through how we could incorporate a feedback loop. Of course, we helped them fill this out. But at the end of this, we were able to come out of this with about 10 to 15 use cases that needed to be prioritized on the basis of business value and technical feasibility. And all those ones that made it in the top right corner, we started working on them or either have them in our pipeline, right? And so one of the ones that made it in that top right corner was the valve failure anomaly detection. And so here we have to analyze discharge temperatures. If we find anomalies here, they could be indicative of a valve failure issue. And if caught in time, that could lead to big savings in time and money for them. And so since we did not have labeled data as to what was an anomaly or not, we had to use outlier detection methods and rely heavily on SMEs to help us understand, what anomalous data looked like for discharge temperatures. We received data every 15 minutes per tag on each compressor. There's about 2,500 units in the fleet, and we needed at least 30 days of data for each unit to understand the stable operating conditions. As usual, you can imagine with this much data, how often we're getting it and just kind of, how it works with IoT data on sensors. The data cleansing took a lot of time here for us. So going through that iterative process, we realized that there were a lot of anomalies coming from when a unit was going down or when it was coming back up that weren't actual true anomalies, or even when the unit was shut down, right? We were getting readings that we shouldn't have. So we had rely really heavily on our SME expertise here when we would read out our demos and show them what our models were outputting as actual anomalies and get their input as to if they would have thought the same thing. So in total, it took about 6 weeks of going through that cyclical process. So 3 full iterations. And then we had the model running internally with our group for just a small subset of units and producing outputs for 2 weeks that the SMEs were checking and analyzing to ensure that they were true anomalies. So once they had confidence in our model and the go ahead, we moved into piloting and deploying that model for a couple of service areas. So our model is currently in the pilot stage. It has been for about 1 month. It runs 2 times a day in our Databricks environment with a really lightweight deployment, outputting our predictions into an Excel sheet that is then, automated and sent out to each service area manager to review, and then dispatch their field service technicians to check on that unit. We are tracking which anomalies are true anomalies, meaning we saw a resulting valve issue, which will help us measure against our KPIs we have set, which include reducing unscheduled downtime events. That in turn saves the organization money by speeding up the call to action and saving the unit from a potential bigger wreck. Things are going well, so we are currently planning for our next rollout phase to other service areas. But before doing so, we want to have a bit more of a sophisticated end-to-end deployment using Power BI as our dashboarding tool to serve up those predictions versus just getting an email in Excel. And so we have decided to engage our change management team in the process so that they can train these new end users how to use the dashboards and predictions and what action should be taken off of them. So that was just one of many use cases that we've been able to productionalize on this project, thanks to the great team I'm surrounded by and those leaders who understand the importance of building up a strong business team who's educated around data science. I really appreciate y'all's time. I hope I was able to drive home the importance of focusing on the people and process surrounding your data science projects. Feel free to use this time to ask any questions. And if not, I have my email up, my LinkedIn up here. You can also contact me through the Slack channel if you want to take this conversation further. But I look forward to connecting with you, and I hope you guys have a great rest of your conference.
Thank you, Gaby. And there's one question from the Q&A session is, was the model predicting failed in advance to the failed, predict maintenance or after the fact of failed?
It was predicting it before it would happen. So that was the whole idea of having it run 2 times a day. When they come in the morning, they wanted to see that anomaly and be able to act on that anomaly before the unit actually went down. And then when it was running in the afternoon, it was taking that data points from the morning and again, seeing if we could act on that before the end of the day and people had to go home and the unit would eventually shut down from the discharge temperature being out of whack.
Okay. So another question is about, can you give us an idea of what your team for this project looked like? How many members?
Yeah, absolutely. So like I mentioned, I was the only data scientist and the data engineer straddling both those roles. In terms of a use case champion, we had those 2 available to us. So the analytics workstream lead and the telematics workstream lead were a part of all of our stand-ups and calls leading that team. We actually have a pretty big team of SMEs and end users. So on all of our calls, I would say we have about 5 to 6 on there, with 3 being actual people who are hands on the ground, and the other ones being people who had done that previously and who are now more on the managerial side of things.
Okay, thank you. And one more question from the chat box is, do you have any experience of people not being on board with the new ML system being implemented, or not fully understanding why they need to change from old way to new way?
Yeah, absolutely. So this is really why we like to engage that change management process and why it's so important to prove the value and have that use case champion. There's always going to be some pushback. We've experienced that a lot, right? These people are really experienced in what they do. So sometimes they think they don't need our model's help. But what we've seen is by actually showing how our model works and showing that we can save them time, we've been able to get them on board, and then having those use case champions behind us really rallying the team together and telling them that they should be using this model. It is helpful. We've been able to kind of bypass that a little bit, but of course that's always going to exist.
Okay, thank you so much, Gaby. So our time is over. So if they have more discussion, we can move to the snack or get a time. And thank you, Gaby, to talk and for being part of the PyData Global 2021. Thank you so much.
Awesome. Thank you.